Okay, good morning, guys. Last section for the week, 6.2, measures of spread. Okay, so this will be the last section for this week. Next week, we're going to focus solely on 6.3. It's a little bit more lengthy, a little bit more in depth, and a little bit more difficult. So we're going to spend the whole week doing that, and by the end of next week, we should finish chapter 6. Okay, so two ideas, percentile rank and percentile itself. So the best way is to look at the examples and then go through it and show you what the question's asking you to do. Okay, so a survey of grade 12, 20 grade 12 female students were asked how long they went shopping for prom dresses. The results for the respondents were as such, so I just ordered them. They have to be ordered from least to greatest. Okay, and then it asks a few questions related. So the first one is calculate the 50th percentile. So basically, what is the number in this data that 50% will be above and 50% be below? So this is also known as a median. We've done this earlier. So here's how you do it according to the formula. Okay, so normally the median would be between the 10th and the 11th entry. That's how we get the median for 20 entries, which we could calculate as 5.5. I'm going to use the formula to show you the same thing. Okay, so we're looking for the rank of the 50th percentile. So I go 50 over 100 divided by 50 divided by 100, multiply that by 20 plus 1. So when I go and do that, I get 5.5. Okay, so that's what number, I get 10.5 here as the rank of the item that I'm looking for. So at the 10.5, I put a little bit of a divider here. This is where the dividing line where 50% would be above and 50% would be below. So from there, I take the 10th and the 11th entry, one on either side, and take the average of that, which is 5.5. So it's 5.5 would be the median and also the 50th percentile. Okay, now we're looking at the 80th percentile. So I just go 80 over 100, 0.8. Multiply that by 21, I get 16.8. So the data entry between 16 and 17, so if this is 20, 19, 18, 17, 16, it's between 10 and 12. Okay, so this would be kind of the dividing line of the 80th percentile. So 10 and 12, when you average it out, averages to 11. Okay, so you actually go and take the data piece. So what data piece is the 50th percentile? Where is the 80th percentile? So it's almost like creating borders to see which values are above and below. Okay, then it says what percentile is a person that's gone shopping 3 times. So we notice that there's 3 people that went shopping 3 times. So here's how we're going to get the percentile rank of somebody that went 3 times. Okay, so to get the percentile, you take 100. L is the number of data points less than the one you're looking at. So that's 2, 2, and 1. There are 3 of them. And then you do 0.5 times a number that are the same. So we have 3 people that went shopping 3 times. So E is the number that are equal. And then you divide it by N, which is the total. So when I do that, I get 22.5% as the percentile. Okay, so somebody that shops 3 times is in the 22.5th percentile. Okay, that one doesn't need to be rounded. And then how about somebody that went shopping 16 times? This person went the second most. So as a percentile rank, where does that rank? So we have 18 that are lower. Only the one person shopped 16 times divided by 20. When you work that out, you get 92.5 percentile. Okay, so that person is in the top of the class, let's just say, in terms of what's been done here. Okay, so 2 simple formulas. Use the one based on what the question is asking you. Okay, and then another concept we're going to talk about is something called quartiles. So these are points that divide the set of data into 4 equal groups or quarters. Q1 is the 25th percentile, Q2 is the 50th, Q3 is the 75th, and if you put those dividing lines, you get 4 sections. The range is the difference between the highest and the lowest value, simple subtraction. Interquartile range is the difference between the first and the third quarters. So it's kind of the middle ground of the data. I'll show you what that looks like in a bit. And an outlier, we now have a definition for the outlier. It's a data point more than 1.5 times the interquartile range below the Q1 or above the Q3. So it's a value that's either super high or super low, 1.5 times the interquartile range. Okay, so let's look at the example. The table lists the height of 20 boys who signed up for the basketball team. Determine the median, range, first and third quartiles, interquartile range. Create a box and whisker plot and identify the outliers. Okay, so let's go one at a time. The median. Here is cumulative frequency. It just helps me keep track of how many people I've counted already. There are 20 in this study that came out for the basketball team. So the median is between the 10th and 11th entry. When I look for the 10th and 11th entry, so there's 1 here, 4 here, we're up to a total of 8. So 9, 10, 11, 12, 13, 14, 15 all go into this category right here, which we average at 172.5. Okay, the range, the highest to the lowest, the highest is 192.5 when we go to the middle, 157.5 when we go to the middle. When I subtract them, this data has a range of 35 centimeters. I did a quick calculation of the first quartile, the 25th percentile and the 75th percentile. It ended up landing at 167.5 and 175. So therefore my interquartile range when I subtract these two is 7.5 centimeters. Okay, so you can take a better look at that. And those calculations, I just did them quick. So now we're looking at a box and whisker plot and an outlier. So a box and whisker plot looks like this. Okay, so this is a method of showing the data visually. So the lowest value gets put a dot here, the Q1 is here, the median or the Q2 here, Q3 here, and the highest value with another dot. You box off, that's why it's the box, you box off Q1, Q2, and Q2 and Q3. And the whisker is the just like a straight line to the from Q1 to the lowest value and Q3 to the highest value. That's box and whisker plot. Okay, so now an outlier. So if the outlier is 1.5 the interquartile range, it looks like this point may be so far out. So we'll take a good look at it, but we're going to take a look at both. So the interquartile range is 1.5 times the interquartile range. So it's 11.25. So any value that is 11.25 lower than this one or higher than this one is considered an outlier. So because Q1, the quartile 1 lands at 167.5, to go 11.25 lower, I'd need a point of 156.25. This one is slightly better than that. So there's no outlier in this spot. But is there one that's 11.25 higher than the third quartile? Well, when I calculate that, it would be a value of anything over 186.25. And this value right here has a value of over 186.25. So yes, there is an outlier, the 192.5. Okay, so that's how you actually find out if there's an actual outlier by doing the calculations. Okay, so a couple of follow-up questions on page 275. Number 3, choose 2 of them. There's 4 to choose from. Pick 2 and do this, what they ask. And then for number 6 and 7, there's all the years from 2007 to 2011. Just do 2007 versus 2011. Okay, and that should give you a good enough idea of what you're looking at. Okay. Again, I'll be available online for some questions and answers. Hope everybody's doing well and taking it easy, and we'll talk to you next week. Have a good one.